All right, so up until now, we've been dealing with exponents that are integers, meaning positive or negative whole numbers. In this video, we're going to take a look at rational exponents, meaning fraction exponents. So anytime you see the word rational, you want to see this root word here, ratio, which essentially means a fraction. So that's what we're going to be taking a look at. And as we've talked about, these are the perfect squares, cubes, and other powers that you should be pretty familiar with. You should basically have them memorized to make this process easier and more manageable. All right, so when we look at these exponents, we're going to be dealing with radicals. So it's important to remember what a radical is, which is essentially the root symbol. And the most important vocab word is the word index, which is the little number inside of the root. So when we have a little 3 there, that means cube root. We're looking for what number cubed equals 27. When we have a square root, so like if we had the square root of 16, there's actually an invisible 2 as the index. We just don't normally write it, but we're looking for what number squared is 16 when we take the square root of 16. So the index really is 2. So if we were to calculate the following, we won't do all of them, but we'll do a couple. When we do the cube root of 8, we are looking for what number cubed equals 8, and that's 2, because 2 cubed is equal to 8. Again, when it's a square root, there's secretly an invisible 2 there. So we're looking for what number squared is 121. The answer is 11, because 11 squared is 121. Now, 4th root of 16, this is where knowing some of those powers by heart is helpful, because 2 to the 4th is 16. So the 4th root of 16 is 2. The cube root of 729 is 9, because 9 cubed is 729, and so on and so forth. So that's why having those powers memorized just makes this process much quicker. Just a quick note about positive and negative numbers. When the index is odd, so when the number inside the root or the radical is odd, we can take the odd root of a negative. So for instance, the cube root of negative 27 is negative 3, because negative 3 times negative 3 times negative 3 equals negative 27. But if the index is even, the radicand, the number inside the radical, cannot be negative. So we say that the square root of negative 16 is imaginary, because there's no number that when we multiply it by itself can be negative 16, because 4 times 4 is positive 16, and negative 4 times negative 4 is positive 16. So it's physically impossible to take the square root of a negative. So if we look at this, which would not be real numbers, which is not possible. So we're basically looking for, are there any even indexes with a negative number underneath? So even index right here, so this would not be a real number. Technically, this is 2, so this is an even index with a negative number. Same thing here, even index, negative number, and again here, negative number. These other ones are real numbers. You can take the odd root of a negative, and so that's okay. And of course, it's okay to take the even root of a positive number. So let's think about rational exponents. What can we determine about a to the 1/2? Well, a to the 1/2 must be the square root of a. Because we know that the square root of a squared is equal to a, anytime you take the square root of a number and square that, you get just the number. And also, according to the power of a power rule, if I had a to the 1/2 squared, 1/2 times 2 is 1, so that would also equal a. So what that's telling us is that a to the 1/2 and the square root of a must be the same thing. So a to the 1/2 is the square root of a. So since a to the 1/2, the denominator became the index, we can conclude that a to the 1 over n is the nth root of a. So the denominator of a fractional exponent is equal to the index of the radical. So 8 to the 1/3, the denominator becomes the index, is really the cube root of 8. 81 to the 1/4, the denominator becomes the index, is the fourth root of 81, which is equal to 3. So if I had 9 to the 1/2, that means my denominator becomes my index. So I'm doing the square root of 9, which is 3. 27 to the 1/3, the 3 becomes the index. The cube root of 27 is 3. 1 to the 1/7, 7th becomes the index. The 7th root of 1 is just 1. And then this is the cube root of negative 125. And anytime we cube root a negative, our answer must also be negative. So it's negative 125. So if I want to go from radical form to exponential form, I'm going to make the index turn into the denominator, 64 to the 1/3. The index here is 2 because there's an invisible 2, 81 to the 1/2. And then I'm going to take the fifth root of negative 32, which is going to be negative 32, and we should write that in parentheses so that we know the base is negative, to the 1/5. So essentially, the index became the denominator. Now, sometimes we're going to have numbers other than just 1 over a number. So we need to go one piece at a time. If it's a negative exponent, we know that the negative exponent means to take the reciprocal. Then we're going to evaluate the root of the denominator, and then we're going to raise it to the power of the numerator. So for 16 to the negative 3/2, step 1 is to write it as the reciprocal, 1 over 16 to the positive 3/2. Step 2 is to take the root indicated by the denominator. So the denominator is 2, so I'm taking the square root of 16, which is 4. And then step 3 is to raise it to the power of the numerator. So 4 to the third power is 64. So this is 1 over 64. So 16 to the negative 3/2 is equal to 1/64. All right, so 81 to the negative 3/4, step 1, write it as the reciprocal. Step 2, take the root indicated by the denominator. So I'm going to take the fourth root of 81. The fourth root of 81 is 3, so I'm going to raise that to the power of the numerator of the fraction, which was 3, and so my final answer is 1 over 27. All right, so step 1 for this one, there is no step 1 because the exponent's not negative, so I don't need to take the reciprocal. Step 2 is to take the root of the denominator. So the denominator was 5. I'm going to take the fifth root. The fifth root of 32 is 2, raised to then the numerator, which is the sixth power, and that's going to be 64. So my final answer is 64.